We want to move on to our last type of confidence interval. These will be confidence intervals for population and variance. And I'm being kind of sloppy with my language a little bit, and that's because these two confidence intervals go hand in hand. And that's because population variance and standard deviation go hand in hand. The variance, remember, is the square of the deviation, or vice versa, the standard deviation is the square root of the population variance. Okay, so we want to make a confidence interval estimate for the population variance sigma squared, and with it, one for the population standard deviation sigma, just like we did for P, the proportion in 9.1, or for mu in 9.2. But there's a problem. Because the variance is squared, it can never be negative. And that means that you can't use distributions that have negative values, like the z and the t. The z distribution and the t distribution both have half of their values on the negative side, because remember, they're symmetric about the mean at 0. Let me go grab a picture of it real quick. There, right here is the t distribution. And you can see half the values are on the negative side for the t distribution. That's not going to be any good to us in a distribution for the variance, because the variance has to be always positive. All right, so we're going to need a new distribution for variance. Let me flip back to the page. There it is. And it's called the chi-square distribution. Chi sounds like a hard k sound, right? Chi-square. And I know it looks like chi, like the t, but it's chi. It's a Greek letter. All right, so we have a simple random sample of size n is taken from a normally distributed population. It must be normally distributed. There are no ifs, ands, or buts. With mean and mu and standard deviation sigma. If you have that, then the distribution of chi-squared, that's what that symbol is. It looks like an X, but it's actually the Greek letter chi. The distribution of chi-squared is normal, or excuse me, follows the chi-square distribution with degrees of freedom n minus 1. Oh, there's that degrees of freedom again. All right, so we have degrees of freedom n minus 1. Now realize that in the chi-square distribution, let me highlight that degrees of freedom n minus 1 business. We don't want that to sneak away from us. All right, now realize that since it's non-negative, that means all the values are greater than or equal to 0. Every last one of them. You'll never be below 0. And that means also that the distribution will not be symmetric. It's actually, in fact, the chi-square distribution is skewed right. Let me just write that, skewed right. Always. But these are still probability distributions, and since they're probability distributions, the area under the entire curve must always be 1. There's nothing else we learn from chapter 5. It's that the sum of the sample space probabilities of the sample space must be 1. Now the x-axis is a horizontal asymptote, but really generally on the right-hand side over here. A little bit on the left, but it ends, it stops. They never go past 0, so they're always going to stop right here. If you remember the t distribution, let me flip back to that page again. There we have it. So the t distribution kind of has an asymptote to the left, and it keeps going. The graph kind of stops, but it keeps going past 5 and negative 5. But the chi-square distribution doesn't do that. It ends at 0. There it is. It stops. It doesn't go forever and ever and ever to the left. All right, and that's what that one says. And then as your sample size increases, your chi-square density curve becomes closer to the z distribution. And you can kind of see that here. This black curve is for degrees of freedom 5. The gray curve is degrees of freedom 10. Now, grant you, they're both skewed right, but do you see how the gray one's getting more like a normal curve? All right, that's all that bottom one is saying. All right, and speaking of which, you can see these chi-square curves, and you finally get to draw all the terrible curves you were always trying to draw earlier in the course. So normal curves and t-curves you have to draw symmetrically, but chi-square curves you have to draw them with a right tail, and you have to draw them as stopping over here. They don't have an asymptote, more or less, on the left-hand side, or if they do, they have a small asymptote, but it stops at 0, which is not technically an asymptote anymore. All right, so now we're going to find some critical chi-square values. So the chi-square distribution Here's the notation for it. So it's chi-squared with alpha and the degrees of freedom. Alpha would be the area to the right, in the right tail. Okay, and then degrees of freedom is df, just like before. And we are going to have to find these with the chi-square distribution table. There is no other option because this is not in the TI-83 calculator, TI-84 calculator. This is only in a table. Now, granted, you could use a computer if you had one available. Excel will find it, StatCrunch will find it, Minitab will find it. But in general, in our course and on our exams, we don't have those options available to us. All right, so I want to determine the chi-square value for 0.99511 degrees of freedom. Now, wait a second. Realize that the entire curve area is 1. So if I have the area to the right, because that's what this is, area in the right tail, such that area to the right. The area in the right tail is 0.995. That means that my value is way over here on the left, and most of my curve is going to be shaded. All right, so I'm going to go draw that picture, and I'll be right back with it. All right, so there we have it. We have this area over on the right, which is 0.995. And you can see I'm looking for this chi-square value, which is this little bitty line right here. Okay, so we got to figure out a couple things. The degrees of freedom is 11. That's going to be the row in the chi-square table. Okay, now we're going to figure out the column. So the column is 0.995. That's because we always want the area in the right tail in the column. Chi-square table. All right, let me grab the chi-square table. The chi-square table is also in your orange packet right here. It's the chi-square table. And you see up at the top it says it's the area to the right. So you want 0.995, that's the area to the right. That's this column way over here on the left. And you want degrees of freedom is 11. So that gives you 2.603. So chi 0.995 comma 11 squared is about 2.603. You go to the 0.995 column, you go to the degrees of freedom 11, and you've got your number. All right, doesn't seem so bad so far. So what about this one? I want the area to the left of the critical value is 0.10. Okay, but that's the area to the left. But remember, at the top of the table, it said it wants the area to the right. So I'm going to have to find the area to the right here. So let me put this in right here. This is 0.90, right? Because if the area to the left is 0.10, then the area to the right is 0.90. So let me write that out. Area to the left is 0.10. So area to the right is 0.90, and this is the column in the chi-square table that we need right there. Right, now the row we need is our degrees of freedom. So n is 34. That means degrees of freedom, which is n minus 1. df is n minus 1. That's 34 take away 1. That's 33. So my degrees of freedom is 33, and that'll be the row that I need. There, I had to put it like that. Okay, so this is the row in chi-square table. All right. So then I'm going to go to my table. I'm going to go to the 0.90 column because that's the area to the right. And I'm going to go to the 33 row. Uh-oh. But 33 isn't in my table. So what I'll have to do is, since 33 is not, df equals 33, is not in the table, use df equals 30, right, as your closest approximation. That's the best you can do. All right, so technically it's chi 0.90 comma 30 is what I'm using, is equal to, because I couldn't get 33. I mean, I wanted 33, but it wasn't available to me. So I'm doing my best approximation I can. So if you want to say 30 or 33, it doesn't really matter because it's all approximated anyway. So you want 0.90, scroll down to the bottom, you can see the 30 there is 20.599. That's the best you're going to come up with. You can't get any better because that's as close as you're going to get. So if you will, what we're doing is we're saying that the 33 value we actually want is really close to the 30 value we can find from the table. And that's what we're going to put. That's the downside to tables. They have limitations. They can only find the values that are actually in those tables. Excel or StatCrunch or a computer program could find them, but your calculator doesn't have this loaded in, so your calculator will not find these. Your only option is to use the tables. That's why I give you the chi-square table on that orange packet in your exams. So bring the orange packet to your exams and you can use it. Or I'll give you a fresh one at the final, and you can use that fresh one with no writing on it. All right, so now I want to find the critical values, chi 1 minus alpha over 2 and chi alpha over 2 for an 80% confidence level, or confidence interval, excuse me. So I'm going to redraw this picture a little bit and fill in the values. So 1 second. All right, there we have it. So I have my two portions labeled. And let me show you where I came up with those. 1 second. Okay, so since my confidence level is 0.80, that means that alpha, which is the complement of that, is 0.20. That makes alpha over 2 equal to 0.10. Okay, and then 1 minus alpha over 2 would be 0.90. Now let me show you that in the picture. So alpha over 2 is this little part right here, 0.10, no trouble. But 1 minus alpha over 2 is for this one over here, because the area to the right of this left-hand bar is the 80 and the 10 put together, which makes 90, 0.90. So you have alpha over 2 and 1 minus alpha over 2. All right, so these are your columns. You're actually going to need 2 columns. So column number 1 in chi-square table. One second. There we go. And then this is column number 1 in the chi-square table. This will be column number 2 in the chi-square table, because you're going to have to find both values here. You can't just do the plus or minus thing you would do for a t-table. All right, then we know that n is equal to 8, or excuse me, 9, which means our degrees of freedom is equal to 8. So that's the row in the t-table. Okay. All right, so we're going to find these 2 values. Let me pull up the table. I need to go to the 0.10 column and the 0.90 column, and I want row number 8. So my numbers are 3.490, there's row number 8 in the 0.90, and 13.362. These values over here on the right, they're on the right-hand side of the curve, and the values over here on the left are on the left-hand side of the curve. It might be helpful to draw a line right down the middle of the table. Feel free to do that. And then these values over here on the right, these values over here are on the left. So let me go type up those numbers, 3.490 and 13.362. And there we have them. The one on the right is the 0.101, that's 13.362. The one on the left is the 0.901, and that's 3.490.